Hi, I'm Katie Morass and I'm a lecturer at the University of Bath in the UK. I'm going to talk to you about some research I've done with my colleagues in Bath in which we tested a new form of computerised support for metacognition and maths learning for pupils with autism. Metacognition refers to knowing what you know and what you don't know, reflecting on your goals and intentions and adapting your learning strategy accordingly. So in the context of revision, for example, this means monitoring how well you know the material in order to revise it further or move on as appropriate, whilst at the same time monitoring your goals and intentions, that's to get the questions right. Previous research suggests that pupils with autism can have difficulties reflecting on their goals and recognising where and when they've made mistakes, and this can lead to problems adapting their learning strategies accordingly. We developed the Maths Challenge computer programme with the aim of supporting young people with autism learning mathematics. The aim of the game was to accrue as many points as possible, with more points available for harder questions. The Maths Challenge was structured in a manner which required the learner to reflect on their goals, intentions and performance both before and after answering each question in order to regulate their strategy accordingly. And they did this by negotiating with the system to increase or decrease or keep the same the level of difficulty and therefore potential points available for the questions. Participants completed the Maths Challenge in either a feedback condition, where they received support for monitoring the accuracy of their answers, goal reminders to get the questions right, and strategy support, for example, to only move up a level if they were getting questions correct, or if they were getting questions incorrect, a good strategy would actually be to move down a level. Or they completed it in a no feedback condition where no support was provided. And we had 40 secondary school children with autism, and in the UK that's aged 11 to 16 years, and 95 typically developing secondary school learners. And contrary to previous findings, we actually found that learners with autism were able to detect when they had made an error. However, they were inconsistent in recalling their intentions before and after answering each question. So sometimes they would say that they were intending to get a question right beforehand, they'd answer the question, and then afterwards they say they actually meant to get that question wrong. Crucially though, providing feedback about performance, goal reminders and strategy support improved mathematics performance for both groups. And these findings indicate that providing support for these sorts of metacognitive abilities can support pupils with autism in educational contexts. You can find out more about this research, which was authored by myself together with Mark Brosnan and Tim Gamble, entitled Supporting Metacognitive Monitoring in Mathematics Learning for Young People with Autism Spectrum Disorder, a classroom-based study, and it's been published in Autism, the International Journal of Research and Practice, and is available at journals.sagepub.com/home/aut. Thank you for listening.